Welcome to Cosmic Conversations. Today we're discussing the fascinating world of asteroid deflection and the progress we've made since the hypothetical 2027 impact scenario. Let's join Dr. Nova and Commander Comet.
Commander Comet, there's been a lot of buzz and speculation about the 2027 asteroid. Can you clarify what that's all about for our viewers?
Certainly, Dr. Nova. I'd be happy to explain. The 2027 asteroid was part of a comprehensive simulation exercise designed to prepare us for a potential asteroid impact scenario. It's not a real threat, but these exercises are crucial for our readiness and response strategies. Let's start with the Kinetic Impactor. This is one of the most straightforward and direct methods we have for asteroid deflection. This method involves launching a specially designed spacecraft to collide with an asteroid at incredibly high speed. The goal is to alter the asteroid's trajectory enough to avoid a collision with Earth. The impact transfers momentum to the asteroid, effectively nudging it off its collision course with Earth. This technique relies heavily on precise calculations and timing.
What kind of speeds are we talking about here? How fast does the spacecraft need to go to make a significant impact?
We're aiming for impact speeds of over 5 kilometers per second. That's more than 18,000 kilometers per hour. The spacecraft needs to be both incredibly sturdy and exceptionally fast to survive the journey through space and deliver the necessary force upon impact.
And how do we calculate the required change in the asteroid's velocity, known as delta V? This seems like a critical part of the mission.
Great question. The delta V is a crucial factor in determining the success of the mission. The required delta V is calculated using the formula dV equals mass of the asteroid divided by 2 times mass of the spacecraft times velocity of the spacecraft. This formula helps us understand the momentum exchange needed. It's all about the momentum exchange ratio. The more precise our calculations, the better our chances of successfully deflecting the asteroid.
And what advancements should we expect by 2027 in the field of asteroid deflection? Commander Comet?
By 2027, we anticipate significant improvements in our tracking algorithms and propulsion systems, which will enhance our ability to detect and deflect potential threats. Dr. Nova...
Ion engines? That sounds like something straight out of science fiction.
It does, but it's actually science fact. These engines are already being tested and show great promise. Ion engines can provide continuous thrust over long periods, allowing for precise trajectory adjustments, which is crucial for long-term space missions.
It's reassuring to know that we're preparing for such cosmic threats with advanced technology. Thank you, Commander Comet, for this enlightening conversation and for sharing these exciting advancements.
My pleasure, Dr. Nova. It's important to keep the public informed. Remember, while the risk of an asteroid impact is low, the stakes are incredibly high, and we must stay vigilant and prepared.
That's all for today's episode. Stay curious and keep looking up.